All right. Good afternoon, chemistry grade 11 learners.
Good afternoon, Miss.
Good afternoon, Miss.
Yes, welcome to our chemistry class. So for today, we will be looking at organic chemistry. All right, so let's just do a quick recap of what we covered in a previous lesson. All right, so last time we looked at the topic which is called alkanes. All right, we defined alkanes as the saturated hydrocarbons, and we also saw that they have a general formula which is given as CnH2n plus 2. All right, and we also discussed that alkanes are unreactive except in terms of combustion, whereby we have both complete combustion and incomplete combustion, right, to produce carbon dioxide and carbon monoxide plus water. Okay, so now when we are saying combustion, we are talking about something burning in the presence of oxygen, all right? So now, okay, we also looked at that the alkanes undergo substitution reactions with the halogens, whereby the halogens, we know those are the group 7 elements, right? Such as the chlorines, the iodines, the fluorines, and whatsoever, right? But in order for this substitution reaction to take place, they have to be a condition that is met, which is the presence of UV light, okay, which is ultraviolet light. All right. Okay. Do we all understand what I just gave a recap on? Can we move on to today's work?
Yes, Miss.
Yes, miss. Yes, miss.
All right. Thank you very much. Okay. So for today, we'll be looking at the specific or the learning objectives for today is we will have to look at describing the alkenes as the unsaturated hydrocarbons, and I will explain what the word unsaturated means as well with the general formula of what? CnH2n. All right, and then we'll also be describing the properties of alkenes in terms of addition reactions with bromine, hydrogen, and steam, all right? And then, of course, you are not required to know the mechanism. That is the work for AS level, all right? Okay, so when we are talking about alkenes, we are saying they are unsaturated hydrocarbons with a general formula of what? CnH2n, all right? What that means is that, or what differentiates the alkenes and the alkanes, okay, is the double bond between the two, okay? So our alkenes, they have a double bond between the two carbons, while as in the alkanes, they just have single bonds, right? So now, when we are, right, just excuse me for that. So when we are talking about the properties of the alkenes, we are saying that the alkenes are reactive because they have a double bond, right? And they react through what we are saying is addition reaction. Okay, we will see in the next slide what I mean by that. All right, and then we have the addition reaction. We already know in mathematics, addition, it means you are taking one thing and adding it to the another one, and then you get your product, right? So now here we are going to see that we mentioned that the alkenes have a double bond, right? So now the reaction of the alkenes with hydrogen, then we are saying that the alkenes, they react with hydrogen so that they form what we are saying is the alkanes, what we spoke about in the previous lecture. All right. So now the conditions that need to be met here is that there should be high temperatures of 180 degrees Celsius, catalyst of which should be a platinum. And then a good example that is given here is we are having ethene. We are saying it's ethene because, of course, it has two carbons and then that is where the word eth is coming from, and then in it's coming from the homologous class group, which is the alkenes. All right, so we are having ethene that is reacting with hydrogen, and then the product that we are getting there is ethane. Okay, so the ethane there, we can already see that it's ending the same way as the alkanes. That is the first sentence that is given there on the top. Okay, so now on top of that, they also undergo addition reaction with what we are saying is steam. Okay, by steam here, you are just having water that you boil, and then of course that vapor is what we are calling is a steam. Okay, now for that, we are saying that the alkenes react with steam in order for them to produce alcohol. Okay, I know, please people, it's not the alcohol that you go buy in the bottle stores here, the one that we are talking about here. Okay, so please don't get the two mixed up. All right, okay, is there any questions so far? Should I continue?
Yes, you can continue, Master.
No questions, Auntie.
All right, thank you. So now the alkenes react with steam to produce what I said is alcohol. Okay, by alcohol here we are referring to, for instance, ethanol, methanol. It can be really any type of alcohol that we utilize in the lab, but we are not talking about the beer here. In beer, there is a percentage of what we are saying is the alcohol. So please don't get the two twisted. All right. Okay. So now, for this type of reaction to take place, it means that the certain condition should be met, which is there should be a catalyst, which is phosphoric acid, and then there should be high temperatures of 300 degrees Celsius plus the high pressure, which is 70 atm. All right, so now when we have ethene plus steam, we get, now in the presence of the conditions that I just previously mentioned, we get ethanol. All right, so this is how ethanol, which is the solvent that we use in the laboratory, is made. Okay, so of course it's made at the industrial levels. Here we are just learning the theory of how ethanol is made, but we will not be making ethanol in our lab, please. We don't want to burn down the school materials. All right, okay, so now we have the next one, which is the reaction of the alkenes with bromine, which we are saying that is a halogen. So again, alkenes react with halogens to form haloalkanes, okay, where we are saying at AS level, they say halogenoalkanes, but here in short, we just say haloalkanes, okay? So we have now ethene reacting with bromine to give us bromoethane, okay, all right? So you can see there that it's ending with ethane, it's ending with the word ane, okay, so meaning that it is an alkane. All right, with that said, do we have any questions, or can we proceed to the class activity?
You can proceed with the class activity.
All right, here is the activity. Can you please just look at it, and then you just take a moment, not too long, just a few seconds to process. And then you just unmute yourself. If you have the answer, you just say, I'm giving the answer to question number 1, and then that is that. All right.
Miss, I'm answering the first question.
All right, yes, go on. What is the answer?
It's because they contain a double carbon bond.
Yes, that is indeed correct. That is indeed correct. All right. So now it's because of the double bond. So meaning that the double bond breaks, and then when it breaks, it leaves a room for it to for something to attach in place of the double bond that have broken. All right, thank you. Question number 2, anybody?
I will be answering question 2. It's because of addition reaction.
All right. Yes, that is indeed correct. It's the name given to that is addition reactions. All right. Can you complete? And then the last 2 questions?
Auntie, I'll be answering the last 2 questions. So for A, the answer is alkaline. Alkaline. And then for B, it's ethanol.
Okay. And
And
then
B is ethanol.
all right. So now we can see there, I think it's maybe just due to the network that is breaking up, but I hope she meant to say alkane for A, and then the last one is ethanol. All right. So thank you very much. That was the class activity. Now, your homework is just to read up on the manufacture of alkenes by catalytic cracking, okay? So that at least when we come for our next class, you have an idea on what we are talking about, all right? And then, is there any questions? Do you have any questions for me before we end of the class?
No, ma'am.
All right, thank you very much. And please don't forget our motto of chemistry of life. Dilute negativity solute by adding what? Plenty of positive solvent. Okay, with that, your life will go smooth. Thank you very much for joining my class. Have a wonderful day and may God bless you all. Thank you. Bye.
Thank you to Miss.
Bye.
Thank you, Miss.
Thank you, Miss.